Okay, so we're going to look at ionic bonding. So I've made a revision card that's got ionic bonding on one side, so I've just got it on the front and then on the back some of the key details. So it's really, really simple on the card, but I just want to make sure that we understand that. Just drop my pen. Hang on. Oop. So we're just going to go through and check that we really understand what this means when we talk about ionic bonding. So ionic bonding is between a metal from the left-hand side of the periodic table and a non-metal from the right-hand side of the periodic table. And what happens is the metal will lose electrons and the non-metal will gain those electrons. So I'm going to give an example here. So for our metal, we are going to use sodium. This is a really common example. So sodium is Na, and sodium has 11 protons and 11 electrons. We won't worry about the neutrons because we don't need that when we talk about ionic bonding. Okay, so and on this side we're going to have our non-metal. We're going to use chlorine, which is Cl, and chlorine has 17 electrons. And that's going to be really useful for us. So the first thing we're going to do is I'm going to draw both of these as their atoms. And when we talk about atoms, we remember that there's no overall charge and the protons equal the electrons. So if we draw the atom for sodium, we're going to put sodium in the middle. This is the electron configuration. We've already said it's got 11 electrons. So in the first shell, we're going to have 2. In the next shell, there's room for 8. And in the next shell, there is room for 8, but we've only got 1 left. So there's 11 electrons there. The configuration is 2 in the first shell, then 8, and then 1. We're going to do chlorine in the same way, but I want to know that these are the electrons that belong to chlorine. So I'm going to use circles or dots instead of crosses. So that's probably ringing an alarm bell for you. Oh, okay, this is a dot and cross diagram, and yep, indeed it is. So here's our 17 electrons on chlorine, 2 in the first shell, 8 in the next shell, 7 in the final shell. So these are atoms, but these atoms are not stable. They're not happy because they don't have a full outer shell. We want to have a full outer shell. So what's going to happen is this metal is going to lose an electron and this non-metal is going to gain that electron. So metal, so the sodium loses an electron and the chlorine gains an electron. Okay, so we've got the sodium loses that electron and the chlorine gains an electron. When that happens, they become ions. So now we're going to draw the ions instead of the atoms. So ions are charged. So they will have a charge. So let's redraw this sodium as its ion. So all we're going to do is redraw it now that it has lost that electron. So it now has a full outer shell because it doesn't have that single electron on its outer shell, but it's got 10 electrons and 11 protons, which means it's got 1 more proton than electrons, which means it has a charge of +1 because protons have a charge of +1. So if we've got 11 protons but only 10 electrons, we've got a proton left over, giving us this positive charge. And the chlorine we're going to redraw as well. And you're going to draw 2, 8, and then on this outside shell, the same as before, except now it has an additional electron that has come from that sodium. So this time we've got an extra electron rather than an extra proton, which means that that ion is going to be negatively charged. So now we've got charged ions, positive and negative. And we know the positive and negative are attracted to each other. So this positive and this negative, they're going to attract. and that attraction is called an electrostatic attraction. And the fact that those two things are then attracted and brought together, that makes your strong ionic bond. So that is why we get this strong ionic bond. And it's really obvious actually, because it's an ionic bond because we're making these ions by gaining and losing electrons. So there we go. There's the information and the dot and cross diagram behind drawing these ionic bonds.